So we're going to move on to Chapter 2, and Chapter 2 has to do with polynomial and rational functions. So pretty much this whole first semester is looking at different types of functions that we've sort of experienced a little bit in some of our previous math classes, and we're just kind of jumping in a little thicker now. So we're going to move on to Chapter 2, Section 1. So 2.1, and these ones are looking at complex numbers. So in mathematics, we start getting into these problems where maybe we have like x squared equals -4. And we actually want to figure out what x is, because x has got to be able to be something since it equals that -4. And so far in our math career, we've really only been dealing with these real numbers. And we know that, like, if we were to go ahead and solve this, you would take the square root of both sides. Right? The square root of -4. And we know that the square root of x squared is going to give us x. But we have the square root of -4. And we should recall or remember that we can't, right now in the real number system, we can't take the square root of a negative number. So real numbers, there's no negative square root for that. So what ended up happening is mathematicians got together, and I think they drank a whole lot of coffee. And in that whole process of drinking a whole lot of coffee, they're like, well, if we can't find a real number, then let's see if we can find an imaginary number. And if we could even go back to like the very beginning of the semester, we even kind of made a little table. We talked about the different types of numbers that there were. So, and we actually split it into two categories. We split it into real numbers and we split it into imaginary numbers. And like if we had like that box, I mean, it literally looked like this. And like this was all of the real numbers and this was the imaginary numbers. And in these real numbers, we had, what was it? We had wholes and we had reals. Well, I guess we already had reals. Natural. What else did we have? We had rationals, which were like our fractions, right? And we listed off a whole list of them. And then under this imaginaries, we just kind of left it blank. And if anything, we can just put in there like complex or imaginaries. So that's where we are today. So now we've kind of talked about the reals. So now we're gonna sit there and talk about some imaginaries, and good time for that. So what they ended up coming up with is they're like, well, we want to figure out a way to represent some number, and we're just going to call that number I for imaginary, so that I squared equals -1. So same thing like that we did up above. If you were to solve this, you would take the square root of both sides, square root of -1. And then we know that if we take the square root of any number squared, that's just going to be the number. So I equals the square root of -1. So that's what an imaginary number is. So an imaginary number, or our I, is really just finding that square root of -1. So how does that help us when it comes to working on some problems? So if we just sit there and take the square root of 25, we're like, well, that's cute, but there isn't anything I can really do with it right now. I would love to have that 25 all by itself, that square root of 25 all by itself, because I know that that's 5. So we can actually split this into the square root of -1 times the square root of 25, right? We're just breaking the number apart. We're just expanding it. And now that we have this imaginary number system, we know that anytime we see that square root of -1, we know that that is I. And then now when we look at this square root of 25, well, now it's a real number. And what's the square root of 25? 5. Yep, good job. And then usually you can leave it as I5. Usually we just kind of put the real and then the imaginary, right? Just for, clerical purposes, but you can do it either way. How cute is that, right? So now that we've talked about just imaginary numbers, well, somehow this imaginary numbers relates back to this thing called complex numbers. So if you think of when we would do fractions, you'd have a whole number, and then you had these fractions, and then we all of a sudden we put whole numbers and fractions together, and we called it a mixed number. So like, 2 and 3/4, that's called a mixed number because it has a real part and then a radical part, or that fraction. So the same thing is going to happen when it comes to complex numbers. So let's talk about complex numbers and what that actually means. So when we want to write a complex number, the formula would kind of be A plus BI. And this would be known as like the standard form of a complex number. So just like when it came to those mixed numbers where it was that whole number and that fraction, so when it comes to complex numbers, kind of the same part. This A, this is going to be our real part. And the part that has the I on it, what's I stand for? Right, imaginary. So this is our imaginary part. So an example would be like -4 plus 6i. And if we look at the -4, we know that the -4 is a real number, so that's our real part. And this here is our imaginary part. Right. And we know that's imaginary because I is technically the square root of -1. Right? So if we wanted to actually go like backwards, if you think of that 6i, right? So you know that that would be 6 times the square root of -1. And if you wanted to get it all under the radical, you'd have to square the 6. So that would be the square root of 36 times the square root of -1, which would be like the square root of -36. Right? And if we've seen it written as square root of -36, we would know that it's imaginary. They just simplified it back to this form. So anytime you see that I is that imaginary part, right? So we might as well start out nice and basic and do some operations. We're not going to like remove the brain or anything, but if we look at operations in math is adding, subtracting, multiplying, and dividing, right? So today we're gonna learn how to add, subtract, multiply, and divide complex numbers. So operations of complex numbers. Or you could just say operations, right? I did not. There. I think I need to work on my palm recognition. I think that's what happens. All right. So might as well start off with adding and subtracting. I know you guys are excited, aren't you? You're like, yes! Alright. So let's say we had, and I'm just going to, I like throwing my complex numbers in parentheses just to start off with because it kind of helps me, I don't know, organize it better maybe. So if I had 5 minus 11i, because I know I have that real and that imaginary part, so I know it's complex, plus, let's go with 7 plus 4i. So I do this little quote-ish reading, I guess, I don't know. And I just say that it is reals to reals, we're not fishing. And imaginary to imaginary. So what do I mean by that? Reals to reals and imaginaries to imaginaries. Well, if we look at our complex number, real and real, so I'm going to add those two together, and imaginaries to imaginaries, imaginary to imaginary, so I'm going to add those together. It's kind of a personal preference. Some people like to group them together. Some people like to go ahead and add it straight out. So like if you were to group it, you would have, your reals would be 5 plus 7, right? Plus your imaginaries, and then you're putting your imaginaries together, negative 11i plus 4i. So we end up with 12 minus 7i. Right? Some of you guys could just look right up here and be like, oh yeah, I know 5 plus 7 is 12. Negative 11 plus 4 is going to give me my negative 7. And then for clerical purposes, it's in that standard form where you got your real and then your imaginary. Right? Same concept applies when you go to subtract. So if we were to subtract two complex numbers, let's say we just had 2 plus I minus, let's go negative 7 minus 6i, just to make it all nice and complicated for you guys. Right? So when it comes to subtracting, it's no different than like when we were subtracting polynomials. The biggest mistake that we make is we forget to make sure we're taking that negative to everybody. Right? So, because this would be 2 minus negative 7, and this would be I minus negative 6i, right? So sometimes when it comes to writing this out, sometimes it's easier to write the negatives out the long way, just so that you make sure that you're taking that negative through everything, all right? Because this would be 2 minus negative 7, right? And then it would be plus I minus negative 6i. So this would give us what? 2 plus 7, right? Plus I plus 6i, right? So 9 plus, how many i's do we have today? We have 7 i's. You guys all good with adding and subtracting? Alright. So once we add and subtract, we can get a little bit more fancy. And let's go with multiplying. So we'll go through 2 examples of multiplying. We'll start with kind of a little easier one to start with, right? Before we throw some little spices on there. So let's say we had 4i and we wanted to multiply that by the complex number 3 minus 5i. So when it comes to multiplying these, almost think of your I like being no different than if that was an x, right? If it was a variable, it works the same way because we're going to leave it I when we go through to multiply, and then we might be able to simplify it, right? So I'm just going to use my distributive property, and I'm just going to do 4i times 3, and then I'm going to do 4i times negative 5i. So that's going to give me 12 i's, right? And then I'm going to do I times negative 5i. So 4 times 5 is 20. I times I is I squared. I always think of, is it Guns N' Roses? I don't know. Sorry. I'll stop. No laughing. All right. So now that we're at 12i minus 20i squared, I'm like, wow, that looks a little different than the last. But I think I remember something. If I go back up to my notes, there was something about an I squared. Where was that? Oop, right there. What does I squared equal? Oh, I squared equals -1. I gotta remember that. Right? So what was that? What did it say? It said I squared equals -1. I'm gonna put a little bubbly around there for us. So any place I see an I squared, guess what I can substitute? Yeah, a -1. So we can simplify this down a little bit farther, because this is really 12i minus 20 times, what are we going to put in for I squared? -1. And then we can just, that would be what? 12i plus 20. And then we can either leave it that way, or if we want to put it in that standard form, which is the reals and then the imaginaries, you could just rearrange that to 20 plus 12i if you wanted to, right? All right. We're going to spice it up a little. Now we're going to multiply two complex numbers together. What? So let's say we have, oh, what did that do that for? 7 minus 3i times, let's go -2 minus 5i, right? So these almost look like factors, right? Remember when we took two factors and we multiplied them together? Same concept applies. We're just going to simplify some stuff at the end, because foreshadowing, I bet you we're going to get an I squared somewhere. So two options. You can do that FOIL, or that distribution property, where you're multiplying through, doing all of this. Or we can do the area model, where we make the square or the box, right? So I'm going to go with the area model just for poops and giggles, right? So I'm going to make me a nice little box. I'm going to separate these. So I'm going to have 7, so my real, and then my imaginary. And then on the left, I'm going to have my real, and then my imaginary, right? And then I'm just going to go through and do I call it my Punnett square, or my area multiplication, right? 7 times -2, -14. This is going to give me 6i. And then I'm going to get -35i. And then I'm going to get a positive 15i squared. I think we're pretty good at doing those, right? So then I'm just going to combine my like terms. So I'm going to get, what do I got? -14. And then how many i's do I have? 6 minus 35 is going to give me -29 i's. And then I still have my positive 15i squared, right? I need to learn how to write straight. This is crazy. I'm going to rewrite it. I'm going to try and do better. So what did I have? I had -14 minus 29i plus 15i squared, right? And we're like, well, that doesn't look a whole lot better. And then I remember, oh yeah, I squared is -1. So I can keep simplifying this down. So I got what? -14 minus 29i plus 15, but I know my I squared is now -1. So that's really like -15. So I got -14 minus 29i minus 15. And you can kind of skip a step or two if you're good with it. And then now I can combine my reals. So I actually have negative 29 real numbers, and I have 29 imaginaries. So I would say that the biggest thing to remember when it comes to like multiplying our complex numbers, if we think of that I as being no different than any other variable, we're good. And then that new piece is making sure that we make that substitution of that I squared equals -1. So once you think that you're good, you're going to want to go back through and see if you have any I squareds. And if you got an I squared, you want to substitute in -1 for that, and then just kind of keep multiplying it through. Because when we get done with these, because the only two numbers that we have, number systems, is real and imaginaries. So when you get done with these problems, you could just like your imaginaries could cancel out and you're just left with a real number, or your real numbers could cancel out and you're just left with an imaginary number, or ultimately you're just going to have a real and an imaginary. So that's pretty much what you always want to get down to, is where you just have a real and an imaginary, or one or the other, right? So like when we got to this part, I mean, granted, we got, you know, reals and imaginaries, but we got that I squared. So I guess that you want a real number and you want an I, right? And you're not a pirate. I know you guys find me funny. I hear you laughing. All right. So we added, we subtracted, and then now we're going to do this thing called dividing. Ooh. Right? All right. So before we get to dividing, we're going to take a moment and we're going to talk about this crazy little word called conjugate. And all you little Englishy people, you guys have heard the word conjugate, right? So it's kind of like taking the opposite of it. So for us, like if we had, really what we're doing is we're trying to get rid of some middle terms. So even when it came to, we started this talk, if it came to perfect squares, you would come up with the conjugate, which is like changing one of the multipliers and then it would cancel out. So in other words, like if we had like x plus y, the conjugate to that would be x minus y. So then ultimately, if you were to multiply these two out, you'd get, here I'm just going to do it real fast, you'd get x squared, and then you would have minus xy, then you'd have plus xy, and then you would have minus y squared. And then this negative x squared plus x squared, those cancel. So you lose those middle terms, and then you're left with, I wonder if I can squeeze it in. Oh, if I had a pen on. You'd be left with like x squared minus y squared, which are perfect squares, right? So that's where that conjugate came in. So if you're, if these are exactly the same and your sign in between is opposite, when you go to multiply them out, it always cancels those middle terms. So this gives us, you know, that no middle term. I'm all about the quotes today, aren't I? Right? So for us, now that we're into these complex numbers, if I gave you, well, I'll just ask the question, right? What is the conjugate? What is the conjugate of, let's say I gave you, I don't know, 3 minus 2i. So the conjugate of that would be 3 plus 2i, right? You're like, why do I care? And if I were to multiply these two babies together, right, 3 minus 2i and 3 plus 2i, I'm going to use the FOIL method instead of the area model just to work this out, right? So 3 times 3 is 9, 3 times 2i is 6i, and And then I'm going to distribute my negative 2i to everything. So negative 2i plus 3 is minus 6i. And then negative 2i times positive 2i is going to give me negative 4i squared. Then now what do I have? 9. My middle terms canceled out. Yes! Minus 4. But what do I know about I squared? I squared is negative 1. So now I have 9 plus 4, which is 13. What? I got a real number. That's crazy. Alright. A little foreshadowing. I feel so Englishy today, but I know I'm not speaking good English. Alright, so let's go back to our divide. I'm going to throw up a clean slate up here. So now we want to divide these complex numbers. Right? Write divide up there again. So, I don't know, let's go with a 7 plus 4i. And I want to divide it, so I'm just going to write it as a fraction, because fractions are our friends. 2 minus 5i. So, complex numbers, if we go back to complex number is that, or has that imaginary part, and that imaginary is the square root of a negative number. And this period is just a square root of a number. And we remember when way back in the day when we would multiply out by our rational functions, we could never leave that square root in the bottom. And the way that this is written, technically that I right there is a square root. It's a square root of negative 1. So we have a square root in our denominator, and we cannot have a square root in our denominator. We got to get rid of that thing, right? So we got to figure out how to get rid of that square root in the bottom. But if I went up here and I did that conjugate and I multiplied by those conjugates, I got a real number. And that real number doesn't have a square root. So anytime we go to divide our radical or our complex numbers, first thing we got to think about is getting rid of that square root on the bottom. So whatever your denominator is, you're going to multiply the top and the bottom by its conjugate. Okay? So for poops and giggles, I'm just going to throw these guys in parentheses. Right? And then I got to multiply by the conjugate. So the conjugate is keeping it the same, but just changing the sign in between. So now I got 2 plus 5i. And if I do it to the bottom, I'm going to do it to the top. Right? Because really I'm just 2 plus 5i over 2 plus 5i. That's just going to cancel out. That's going to be 1. So I'm not changing the problem any. So now I just got to multiply the top and the bottom. So area model. You guys like area model? We'll do the top with the area model, and then we'll do the bottom maybe with the FOIL, right? So on top I'd have 7. If you want to do the plus 4i, and then this would be 2, and this would be a positive 5i. You don't have to put the plus there if you don't want to, right? So we're going to jam through this. So we're going to get 14, 8i, 35i, and 20i squared. So sometimes on this part, because I know that my I squared is negative 1, I know that this is actually going to be now negative 20. If you want, you can do that. You don't have to. Like sometimes I do it just to kind of save some space, but by no means do you have to. You can write the whole thing out, right? So now I'm going to combine my like terms. So I got these two guys, 14 minus 20. That's going to give me negative 6, right? And then how many i's do I have? I. 43 of them, plus 43i, right? So I got my top. So now I just got to figure out my bottom, right? Oop. So on the bottom, if I wanted to do 2 minus 5i times 2 plus 5i, right? 2 times 2 is 4. 2 times 5i is 10i. Negative 5i times 2 is negative 10i. And negative 2i times a positive 2i is going to give me a negative 25i squared. Luckily my middle terms canceled out because that's what I want, so I'm going to check to make sure that they do, so that way it helps me out. And then my I squared, we remember that's negative 1, so this is actually now going to change to a positive 25, right? So now I got 4 plus 25, which is going to give me 29. So if we, and I'm fine with the answer written this way, but if we actually wanted to make sure that it was back to that a plus bi form, you're just separating your two fractions. So this would just be negative 6 over 29. That would be your real part, plus 43i over 29. And then that's your complex part. And then now you can look at each one of these fractions. Like, can I reduce that? Is there a number that goes into 6 and 29? No. And then I can do the same thing over here, right? Looking at that reals to reals, that 43 over 29, is there a number that goes into both of those? No. So we're going to leave it the way that it is. So now you guys have just divided complex numbers.